So when can we use this binomial distribution? Well, it'll be used for a discrete random variable that's very specific. Each trial has only two possible outcomes, usually refer to them as success and failure. Be very careful when you use success. Make sure you're looking at the study or whatever the question is, because sometimes what we think of as success could be the number that you get wrong versus the number you get right on like a quiz. The outcomes of the trials are independent. The probability of success remains constant, so it can't change. If the probability changes, then you cannot use binomial on each trial, and that probability, we use p, small p for that. The random variable of interest, we'll call it capital X, is the number of successes in a fixed number of trials, and we use the number n for the number of trials. We could also, instead of using capital X, we could use something that makes more sense in the context of the problem. But the notation, here's where it says the random variable X. It follows that it is modeled by the binomial distribution n trials. In the example we did earlier, there were 5 questions. And P is that probability of success, and it's constant and it does not change. In this case, N and P are called the parameters of the binomial distribution. We showed earlier that this is the probability distribution. Remember, the sum of the probabilities must total 1. It can be shown the expected value instead of having to do what we did before, which was it could be very timely. It could take a long time to calculate the expected value. Here, as the probability does not change, and we have just 2 options, we can do n times p, and the variance is n times p times 1 minus p. So the standard deviation, of course, for that x is just the square root of the variance, don't forget. The long run average of number of successes, so that's that expected value, is just the number of trials and times the probability of success. Now, in this class, we do the calculations manually. For large values, you could use an applet, an Excel, binomial distribution. That's the name of the function in Excel, or a scientific calculator will frequently have this as an option for binomial. Now let's go back and wrap up that question we were working on. Suppose that you must answer at least half of the questions correctly in order to pass the 5-question quiz with 3 options per question. Determine the probability of passing, assuming you randomly guess on each question. So we have to get at least half of them right. Well, what is half of the 5 questions? That would be 2.5. Well, when would that happen? We have the distribution here. We know it's going to be, all of these. P of x equals 3 plus P of x equals 4 plus P of x equals 5. If you add those probabilities together, you're going to get 0.209. Now, would you expect this probability of passing, in other words, getting at least half correct, to be larger, the same, or smaller if the quiz consisted of 15 questions rather than 5? And explain your reasoning. Well, if we think about it, you could guess, possibly going back to the top here, maybe you're lucky guessing with 5. But what if we go to 15? Do you think is it more likely that I can tell that you're just guessing, or less likely? Well, it's more likely to see that the more trials you have, the more likely it would be to see that just guessing. So if I can more likely see that you're guessing, the probability of passing is going to be smaller. It's going to go down. It becomes more apparent to me that you are just guessing, so the probability will go down. If you're struggling with that concept, think about if you have like 2 questions. So you had 1 and 2, and you had A, B, C, and you got them both right because you guessed A. Do you think you would guess A on all 15 of them if A was just the answer? And the answer is no. So it's easier to get lucky with a smaller number of trials than with a larger number. How would you expect the probability of passing the 15-question quiz to change if you had 5 options rather than 3? Well, now if you think, just thinking about it, you have A, B, C, D, and E to choose from. Oof. So the probability, if you're just randomly guessing, of getting one right, instead of being 1 out of 3, it's now 1 out of 5. Probability of passing is going to go down. 5 choices, you're even less likely to guess correctly.